In this video, we'll demonstrate how to code check a prestressed beam with openings. Start by selecting Detail 2D, then set the concrete and reinforcement, and then define the concrete cover. Now define the cross-section of the beam by adding member entity. Now select the shape of cross-section in Cross-Section Navigator and then define the parameters of the cross-section. Now, modify the length of the beam and activate option haunch. To create a haunch, click on the plus icon to create a new cross-section. Change the height of the beam before clicking OK. After that, set the alignment to bottom. Copy member M1 to create a new member M2. Modify the position of M2 by changing the master and insertion point so that it is connected to member M1. To apply opening, choose opening in the model subregion. Change the shape of the opening from rectangular to circular. Then adjust the size and its position. To apply another opening into another location, simply click on copy, then adjust the size and then modify accordingly to its position. Now that opening is set, let's add some support to the beam. Select point distributed under support type in subregion. Then add it at each end of the beam. Now let's specify some load case. Create load case P under load case type prestressing. Copy the same case and rename it to SW, then apply self-weight under load impulses. Load case type should remain under prestressing. Click copy once again to create another load case G for permanent loads. Then apply the concentrated loads into the beam. Click on copy to create another load case Q for variable loads. Then modify the concentrated loads. Now let's create a load combinations. Click the combination icon to create load combination C1 for ULS. Then copy to create C2 and C3 for characteristic and quasi-permanent for SLS. Apply partial factors for nonlinear combinations for ULS and SLS. Activate deflection check for load KC2 and crack width check for load KC3. Now let's apply the prestressing strands by selecting prestressing in the model subregion. Choose pretensioned under prestressing type and modify the number of strands. Change the long-term losses to 13% and modify the position of the strands. There are 3 layers of strands, so do the same steps to other layers of strands. In Tools tab, click on Topology Optimization to see the compression and tension field. This can aid designers to facilitate reinforcement layout. Now let's apply reinforcement by clicking on rebar assembly icon and selecting group of bars. Use 12 mm diameter for group of bar GB1 and modify the reinforcement by changing the parameters. Copy to create group of bar GB2 and GB3 and repeat the process by changing the reinforcement parameters. Now let's add stirrups to the reinforcement by once again clicking rebar assembly and by choosing group of stirrups. Use the same 10 mm diameter bar but modify the spacing according to specified requirements. Now create a copy of that stirrups and apply it to master M2 and change measured from to from end. Now let's add trimmer bar reinforcement to those openings by once again clicking on rebar assembly and choosing cages around opening. Modify the parameters of the trimmer bars and apply to the opening. You can then copy this and apply it to all openings by changing master to opening 02, 03, 04, 05, and 06. Now that we have completed the modeling of reinforcement, one can now analyze the beam by clicking on Calculate. We can now review the results by moving to Check tab. Under Code Check Results, we can review the result summary, the strength of concrete, reinforcement, and tendons as well as its anchorage under the criteria for ultimate limit state. The same goes with serviceability. We can review the stress limitation, crack width, and deflection for serviceability limit state. And lastly, generate a calculation report. You now have code checked a pressed rest beam with openings.